Rob Carter is a marine biologist, so he took me scuba diving to get a glimpse of a world most people don't see. His specialty was coral, and he knew a lot about the incredible creatures that inhabit the reefs around St. Thomas.
Oh man, we got the sharks here. I mean, just look how they move. I mean, it's almost like effortlessly glide along. I wish I could swim like that.
Engineers wish we could make boats like that.
Yeah.
Submarines that can move as efficiently as a shark, we can't quite do it.
So, from your perspective as a marine biologist, and I know that you've studied the whole area of genetics a lot.
Yes.
When people talk about evolution, what is it?
How do you define evolution? The word means change over time. But I believe in change over time, but I'm not an evolutionist. So how does one figure this out? Really, evolution is a belief that enough change over time, over enough time, can lead to the common ancestry of all species on Earth.
All right.
So that's the part I reject. Of course species change. I mean, look at these sharks here. We have several different species of sharks. When God created, He put into those organisms the ability to change, to adapt, to respond dynamically to the environment. But they're still sharks. And when we look at the fossil record, they're still sharks. You know, people have heard the phrase, the missing link. Right. And they usually think of between man and monkeys. No, there's missing links between almost every major group of animal and almost every other major group of animal and plant, even bacteria, throughout the entire fossil record, which indicates very strongly that these are actually different creations.
So we don't get one kind becoming another kind?
No. Evolutionary theory requires that small, random changes can explain everything we see. But it can't.
And why can't it?
Because life is so complex that small changes can't explain it. Just like you can't take a computer operating system and look at it and say, oh yeah, this is built up one digit at a time over any length of time. No, it took an intelligent person to sit down and put it together.
Well, I can guarantee you, as one who was in that world, that if anyone in the area of computer science were to say, if we just randomly change some things in this operating system, it'll get better. I mean, no one would agree with that.
No, we're not going to get the shark to evolve into a bird. That the number of changes and the types of changes are not something that you can do one change at a time. This is a sea urchin.
It looks spiny.
It's pointy. You got to be careful.
Am I going to get stuck if I touch it?
No. He's pointy, but...
Oh my goodness, they're moving.
Yes, they're moving. And in between the spines are little tube feet, especially on the bottom. Oh, look at that movement. So he walks with his spines, but he's little tube feet in here, and that's what he uses to grab onto things. But looking carefully, there's 1, 2, 3, 4, 5, 6, 7. There are actually 10 radial parts to this animal. Actually, the starfish is his cousin.
Are you serious? You can't be serious.
Absolutely. The starfish here is also an echinoderm, but notice he has 5-fold symmetry instead of 10.
Yeah.
This starfish does. On the bottom, look. We see the spines, we see the tube feet. His mouth is in the center there.
So there is some similarity here, even though externally it looks a lot different.
A lot different. Actually, you want to see something that looks a lot different?
Sure.
Which is a cousin to the starfish and the sea urchin?
All right. It almost looks like a rock.
Yes. I got to be careful. He's squirting on me. This is a sea cucumber. He has spines. He has tube feet.
Oh, my goodness.
You would never know it until you studied really hard that this also is an echinoderm. He's not very happy being out of the water, so let me put him back in.
Yeah, so these are all related, even though they look very, very different.
Related in their creation. Not in an evolutionary sense, but our Creator took this phylum of life, the echinoderms, and created this and this and this on a similar pattern. And that's what we see across the entire realm of life, similarities and differences.
So what makes them different?
Well, genetically, they share most of their genes in common. But there are developmental genes, they're called Hox genes, that set up these patterns in the animal as it develops. They develop from a single cell. In one of them, they set up a 5-fold symmetry. Another, they set up a 10-fold symmetry. Another one, they make this long, skinny animal. They control the development of the embryo in these amazing ways.
So what you're saying, when we look at this from a molecular or genetic perspective, what we're finding is really a fascinating design in all of that.
Absolutely.
But what we've heard in the conventional paradigm, the conventional story tells us that it's those random changes that has brought about all of this.
Sure. Back in the 1800s, when life was simple, when they didn't know what was happening inside the cell, they didn't know how complex genetics was, you could imagine all sorts of things. But now that we know what actually happens behind the scenes, the story gets a lot more complicated. You see, I like to say the genome is four-dimensional. Well, we have a one-dimensional string called DNA. And if you want to draw that out, you'd have to write all the letters of DNA out on all 3 billion of them. And then you have to draw lines or arrows from one part to another part, because this part turns this part off, this part interferes with this part enhances this. It's this huge two-dimensional interaction network. And that's why you have a two-dimensional genome.
I mean, let me stop you for a second, because this is really amazing to think about this, because I think in terms of a computer program that it's fairly static. I mean, the instructions are there, but you're talking about a program that is reprogramming itself. It's modifying its own instructions.
Oh, wait till I get to the fourth dimension.
Oh, okay.
Because of the third dimension first. The information in that first dimension, that linear string, has to be organized in such a way that when it falls into the third dimension, it still works.
Oh, that's amazing.
Genes that are used together are next to each other in 3D space.
Are you saying that once this thing gets folded up, it's almost like we have a new set of instructions?
Yes, a new level of information.
Unbelievable.
That whoever programmed that first level needed to understand what was going to happen, have it work in the third level.
But you said there's another dimension even.
Oh yeah, the fourth dimension is time.
And how does that work?
The genome changes shape over time. Maybe you eat something that's bad for you, and your liver says, I can get rid of that toxin. Now, the chromosomes in the liver will change shape, expose that new protein gene, make copies of it, build a brand new protein that can kill off that toxin, and when it's not needed anymore, they'll change shape again and fold back.
Oh my goodness.
Dynamic programming. All 3 levels change in the 4th level, time.
Rob, that's so far beyond anything that we know, even in our most complex software systems, that it's almost beyond imagination to think that someone would look at that and say it all happened by chance.
Yes, and it only brings glory to God.
It does.
You can't build something like that up one thing at a time. You need it to function. In all this interlocking 4-dimensional complexity, it's not something you can do one letter at a time with natural selection.
It all has to be there.
Yeah, in the same way when we talked about the environment out here on the coral reef, if you don't have all these interlocking pieces of that puzzle, you don't have that ecology. The system will come crashing down if you just remove a couple of very important factors that are there. They have to be together or it doesn't happen.
So not only did we have this interdependency, this mutualism, so to speak, down at the genetic level, now we even make it more complex by saying there is that same mutualism at the higher level as well.
Yes. In fact, the entire world has a mutualism.
It's impossible to think that all of this could have happened just by a series of slow processes over billions of years.
That's exactly what I'm saying.
Doug took me to one of the best archaeological museums in the world to show me some of the unique artifacts that relate to Genesis.
Well, the events of the Bible are unfolded in the ancient Near East. So all of these lands are extremely important to understanding how and what took place in the biblical text.
So this picks up these events we've been looking at in Genesis, from creation and the flood, and now we're to the dispersion of mankind out of Noah and his family.
Exactly. And the dispersion would have taken place somewhere in this mountain range to the northwest of Mesopotamia. And what we see in the biblical text in the narrative is that a number of people have migrated down to southern Mesopotamia, the land of Shinar, and moved toward the process of urbanization, city living.
And that's the famous Tower of Babel.
Absolutely.
Do we know where that is?
There are about 7 or 8 Babels, cities of Babel, in the ancient area of Mesopotamia. And so one at a time, I've studied all of those areas and found only one that meets all the criteria of the famous site of the Tower of Babel, and that is the site of Eridu, which is in southeastern Mesopotamia. We have signs of the expansion to the north, to the south, to the east, to the west, all the way as far as Egypt.
And when you say evidence, that is the artifacts that we find in these archaeological digs?
Exactly. There's an enormous amount and very specific kinds of material culture that attest to this expansion of people that I'm connecting to the post-Babel dispersion. Here are the beveled rim bowls, these two, which is that Rimkin brick that we see up there, and those two spouted jars. All of these diagnostic forms of pottery and material culture, they're found throughout the Near East. The Bible describes an event that's not just the confusion of language, but it's the dispersing of people far from that city. And because we see language or the written expression of language just pop up out of nowhere, and then different languages being represented through cuneiform script or through hieroglyphic script or other means. So you do not have a universal plan that's followed among all of the languages. You see great diversity in the forms of grammar from language to language, even in ancient languages.
It seems then that the event recorded in Genesis about the Tower of Babel, that's a very, very critical event for archaeology.
It is. So all of this fits perfectly with what we would see as the biblical account of how languages took place. It's really the only way of explaining this. So the integrity of biblical history ultimately is justified by the expression of these languages.
Now, most of us think today of a tower, the kinds of things we see in big cities, big straight walls. Is that what they were building?
Well, essentially, it's a variation of a pyramid. And there were 4 sides to it and several stairways that would go up to the top. At Eridu, we have a temple that existed in 18 different phases. And in every phase, it grew in its size and its complexity. And that final temple, that final phase of the temple, it was abandoned immediately, right at the time of the late Uruk expansion. Catacorner to the temple was an absolutely enormous platform.
Do you think that could be the foundation of the Tower of Babel?
Absolutely, and I would suggest to you that this late Uruk expansion, where this technology began, was something that spread with the people. We find forms of these ziggurats all around the globe. We find them in China, we find them in India, we find them in various parts of the Americas. We find them all over.
Well, obviously we have evidence here of civilization and people beginning to gather together in communities, even cities. Do we have any other evidence of that?
Absolutely. We can move forward to the time of Abraham because we know that Abraham lived at the site of Ur, which was also in southern Mesopotamia, at the end of the 3rd millennium BC.
That brings us to the end of Genesis chapter 11.
Exactly. In fact, you see some pottery, some cuneiform tablets, all dating to the period of the 3rd dynasty of Ur.
It's amazing just as we're sitting here thinking about that, thinking about Abraham and that this represents the culture and the civilization that he lived in. It's a great tie to that record in Genesis for us.
It is fascinating, and it gives you a feeling of putting your hands around the events that go on in the biblical text.
When I look back through history, I realized each of these cultures had been impacted by the events recorded in Genesis. But what is the importance of Genesis to us today?